with what we covered the last time, let me just remind you of the new quantum assumptions that we have been introducing. So we did the black body radiation, and really the thing that you get out of black body radiation and photoelectric effect is this relationship. Let me label this quantum or quantum mechanical assumptions. This is something new, as I've been emphasizing since last time. This is not something you can derive from what you already know in classical mechanics. So one was that energy of a photon, that you can treat light as a particle. We give it a name, photon, and that energy of that said photon is Planck's constant times frequency. This is a break from how we are used to treating electromagnetic wave or light. And the second assumption that I introduced, we didn't do much with it last time, is the de Broglie relationship. You can actually derive from here with a little bit of special relativity, but the end result is that momentum, or how do I put it? That for everything that is a particle that has momentum, it has a wave characteristic. And there are those particle and the wave side of that thing is related by this relationship. Momentum is equal to Planck's constant divided by wavelength. So this is the de Broglie relationship. And it's best understood as a kind of a gateway, actually. So all of you here have taken physics 4A. You are hopefully reasonably comfortable with dealing with the particles, things that have momentum. So whenever you are describing something that has momentum, then you are used to describing this as either, mass times velocity, or if you're in special relativity, it would be gamma mv. And so this is describing the particle side of whatever it is that you are describing. So this is the particle property. And what de Broglie relationship is proposing is that this particle property is related to this wave property. Because, unless something is a wave, it makes no sense to talk about its wavelength. When we are dealing with this steel ball in classical mechanics, we didn't talk about wavelength of this ball because that would be nonsense. What we are saying now is that in this strange world we live in, it's not a nonsense, that this particle has wave property, and the wave property of this object is related to its particle property by this relationship. And this is not something you can derive from anything. It's, so that's why I'm calling them quantum mechanical assumptions.